talk about special right triangles. This is something that you learned in geometry, and it's honestly something that will save you a lot of time if you can have these memorized on the ACT, because there's always one or two questions that if you know the rules for your special right triangles, you'll save a lot of time. I want to start with the 30, 60, 90 right triangle. Every 30, 60, 90 right triangle is going to be similar, so the ratio of the sides is always going to be the same. And I want to help you discover the rules about a special right triangle. The leg that goes across from 30, I'm always going to call it the short leg. This will always be the hypotenuse. And the one across from 60, I'm going to call the long leg. So we can kind of see, if we just automatically want to start with the fact that this across from 30 is 1, or we could call it x if we want to find the ratio. If I drew in a triangle on the other side that was a similar triangle and made it 60 and 30, we could say that this is also 1. And what we've just found is the fact that we have a 60, 60, 60 triangle, which is equilateral and equiangular. So since now this entire side is 1 plus 1, which is 2, then that means that all of the other sides are going to be the same. So this side would be 2, and this side would be 2. To find this third side of our smaller triangle now, we can use the Pythagorean theorem. We can say that the long leg squared plus the short leg squared, which was, we'll go ahead and just do this, is going to equal the hypotenuse squared. And we don't know our long leg, that's what we're trying to find. Our short leg was 1, and our hypotenuse was 2. So long leg squared plus 1 equals 4. So long leg squared equals 3. So the long leg equals the square root of 3. So we can see the relationship in every 30, 60, 90 right triangle. If the short leg is x, then the long leg is going to be whatever the short leg is times the square root of 3. And the hypotenuse is always going to be 2 times the size of the short leg. So it's going to be 2x. So for instance, let's say my short leg was 4. My long leg would be 4 squared root of 3. And my hypotenuse would be 8 because it's always doubled. So this is the relationship that you'll always use in a 30, 60, 90 right triangle. Let's talk about the other special right triangle, which is a 45, 45, 90. In this case, let's do the same thing, and let's say this side is 1. So that side would be 1, because in a 45, 45, 90 triangle, it's isosceles, so those sides would be the same. We can find our hypotenuse by doing the Pythagorean theorem. The hypotenuse squared equals one of the legs squared plus the other leg squared. So the hypotenuse squared equals 2. So the hypotenuse equals the square root of 2. So the relationship in a 45, 45 triangle is the leg, and we don't have a long leg and a short leg this time because they're the same. If the leg is x units, then the hypotenuse is x square root of 2.